next is the loss due to the creep of concrete. The creep is a time dependent deformation due to the permanent force. In the pre-stressed concrete, the pre-stress is a permanent force in the member, causing the compressive stress at the level of the steel. Hence, there is a creep strain in the member. It is the stress in the concrete at the level of the steel. So the creep of the concrete, as it increases with the deformation with the time under the constant load. Due to the creep of the concrete, the stress in the tendons is reduces to the time. So in this, what are the effect of the creeps? What does the necessary for the PSC? So there are some cases we can observe. In this, the effects of the creeps is in reinforcement in the concrete beam. The creep increases the deflection with the time and maybe critical consideration in the designing. And another is the in the eccentricity loaded column, the creep increases the deflection, and it can also be caused for the buckling. So this is the effect of the creep in the sections. So how we can able to reduce this creep? It can be easily reduce the creep by minimizing the amount of the water possibly when which is being used in the while mixing the concrete. So that is the only possible way. And another is the too large by using the larger coarser aggregate. The some extent the reduce it can creep can be reduced. The compression steel also reduces the creep. For example, if you take a compression steel in a concrete beam, reduces the long-term deflection. And what are the if you want to know about the more about creep of the concrete, you can go and go through the MSHT concrete technology by MSHT. You can go in detail. So that is about the only about the uh, this creep of the concrete. Apart from that, now when we come to the uh, PSC sections, in this the concrete, the whatever the loss in the creep in the pre-stress member, which is resultant in the effective reducing the stresses in the high tensile steel sections. So in this, the factors influencing the creep of the concrete, we will discuss. The loss of the stresses in the steel due to the creep can be estimated if the magnitude of the ultimate creep strain or creep coefficient is known. This can be calculated by ultimate creep strain method and creep coefficient method. In this, the loss of the in the ultimate creep strain method, the loss of the stresses in the steel can be steel due to the creep is sigma cs fc into ec, where epsilon ec is the ultimate creep strain of the sustained unit strain, and fc is the compressive stress in the concrete. That I will show you. See here. So this is the formula which is being used. Epsilon is cc into fc into es. So this is the formula which is used for the loss of the stresses in the steel due to the creep of the concrete. This is by ultimate creep strain method. So that is for ultimate creep strain method. For that one, the loss of the stresses will be determined. So next is the another method is the creep coefficient method. In the creep coefficient method, it is the ratio of the creep strain to the elastic strain. So by finding the creep strain and to the elastic strain, we can find out the creep coefficient. In this creep coefficient, uh, and that is only a coefficient to determine the loss of the stresses in the steel. Okay, so after finding the creep coefficient, you have to the stresses in the concrete and modulus of elasticity of the concrete, it will be known. By knowing that and multiple with the creep coefficient, we can able to find out the creep we can able to find out the creep coefficient. Okay, so that is about uh, the creep coefficient method. So only that is a small description. You can go further in the here in detail. See here, the creep coefficient is given by the ratio of the creep strain of the concrete to the elastic strain of the steel. Okay, so that is a coefficient. So that multiple by the elastic strain of the steel. Okay, so epsilon c is the creep strain is equal to creep coefficient. You can see here. You can see here, creep coefficient is equal to 5 into epsilon e. So that is nothing but creep strain in the concrete is equal to creep coefficient of the epsilon e, that is elastic strain in the steel. Okay, so that's what we have to determine. That is also equal to the epsilon into fc divided by ec. Phi is the phi is the creep coefficient. Fc is the strain in the concrete. E is mass of the concrete. Okay, so finally the loss of the steel. Here finally what we have to determine is the loss of the stresses in the steel. You have to find it. So you know that creep strain epsilon c is the creep strain into ec, that is the modulus of elasticity of the concrete. Epsilon c is the creep strain of the concrete into the modulus of elasticity of the concrete, and phi, the phi is nothing but creep coefficient, or that is the creep strain by elastic strain into the es, that is the modulus elasticity of the steel. By knowing this, we can able to find it. So to make it very simple, so you can go to the final, that is also equal to the phi fc into alpha e. So that alpha e is nothing but a modular ratio. That modular ratio is the fc divided by ec. That is nothing but a stress by Young's modulus. That is the fc. Okay, modular ratio is alpha e. Phi into fc into alpha e. Phi is the creep coefficient, fc is the stress in the concrete, and the phi e is modular ratio. Finally, the loss of the loss due to the creep of the concrete in can be determined by finding the loss of the stresses in the steel, that is equal to 5 fc into alpha e. Okay, so this is how you have to find out the losses of the stresses in the steel by due to the creep. Okay, in this, the magnitude of the creep coefficient phi varies depending upon the humidity, concrete quality, and duration of the applied of the load, and the age of the concrete when it is being loaded. Generally, the recommended value for the creep coefficient varies from 1.5 for the water conditions, and 4 for the dry condition, with a relative humidity of 35%. In the British codes, the structural concrete recommends the design value of the ultimate creep strain of 48 into 10 to power of minus 6 for the pre-tensioning, and 36 into 10 to power of 6 for the post-tensioning. These values have been increased with varying proportions with the concrete strength of the concrete, which is lesser than the 40 Newton per mm square. Okay, so this is about the loss due to the creep of the concrete.